Okay. And wait a second. And it's not there. Probably because I didn't add it. So let's check it one more time. Okay, so this is y equals 0 0.5. And you can see as the coin flips are being added, this line is converging towards a half. Next thing to do to make this look a little cleaner, I'm just going to add lines connecting each of these dots. And so what I'll do is, I guess for each of these dots, actually I can just do it in here. Just do another for loop. And here I'll do for dot and graph starting. I have to do a zip, right? I have to do for start, end, and zip. I'll do graph up to, not including the negative first entry, and graph from the first entry onward. Why does this keep moving to the left? I'm going to create a line. Wait, my formatter is doing something weird. Yeah, I'm not sure why it's doing that. Okay, it stopped. And I'm just going to add a line. So I'll say line equals line. It's going to go from start.getCenter to end.getCenter. And I'll just add it to an array. And then at the end of that, I'll say graph.subobjects equals lines plus graph.subobjects. So this is going to put all of the lines before all of the dots. And so that will make the dots appear on the top. And so let me just add them to that array. Oh. Wait for some rendering time. Meditate. Feel one with the code. Okay, that's almost done. Oh, hey, and it's doing what I expected. When I was preparing for this, the first line appeared on top of the dots, and I had no idea why. But it's not doing that anymore. And okay, so now you can see that this is the random distribution of those heads and tails. And over time, this graph is getting closer and closer to 1/2. There's probably a way to sample this with a chosen probability. Probably. If I open a Python shell, so you just go to help. There's got to be a way to weight these things. Like this, choices, return a k-size list of population. No, that's not what I want. Sample population k counts equals none. Yeah, whatever. There's probably a way to do it. I don't know what it is. So instead, I'm just going to put another 0 here. And this is going to weight it toward 0.33. Okay. That's almost done. Yeah, now you see that instead of getting closer and closer to this line, it's coming around where you'd expect there to be. Great, so that's one example of doing the simulation. I think you got to do the k choices one, just with k equals 1 in order to do weights. Okay, I'd have to look at, I can come back to this and try to do it at a later time. But for now, it's not related to Manim, more of a Python thing. So I think that's fine to leave for now. Great. So this used a few concepts. This used the always redraw. This is good for anything that's updating all the time, every frame. And it shows a really good use of value trackers, because without value trackers, it'd be difficult to do an animation like this. Okay, cool. So I'm going to go to the next one. For the next one, as you can see, if you're following the notes, I'm going to do a scene to estimate the value of pi. Is redraw basically the same as dot become? It's similar, pretty similar. Dot become is where you pass in a mobject. You do like mob1. You do something like mob1 dot become mob2. And here we're passing in a function. So we'd have to do something like create the graph on the first frame. Then on every other frame, call that graph dot become another graph that we create. But you could do it with become. All right. So for the pi estimate, you've probably seen this estimate before, where if you have a circle inscribed within a square, you can sample random points within the square and determine pi based on how many of them appear in the square, in the circle, and in the square. And so we're going to do that. So I'm going to say square equals square. Circle equals circle. I'm going to scale both of these. I'm just going to call it a scale factor. And that scale factor, I'll just put at 3. Then I'll just add these. Actually, I'll add them to a group. So I'll say group equals a B group with a square in the circle. And I'll add that. So I just update my shortcut here. Okay. And I already messed it up. I have to wait. Perfect. Let me set the color of the square to red and the circle to blue. Great. So now what I'm going to do is I'm going to sample random points within the square. So that's going to require using a value tracker or something to track the time. What happened to my music? There's like the one time I wasn't mad about it and then it just stopped. There we go. Okay. So let's bring in a value tracker. And I'm going to move its value to say 10. And I'm going to do it linear. And the runtime will be 10. So now it's going to basically behave as a clock, just going for 10 seconds. What I'm going to do is add an updater. So I'll call this update points. It's gonna have to take up object. What I ended up doing is adding this to the... I guess I'll add it to the square. Update points. I'm gonna add this to the square just because I have to add it to something so that I can call it on every frame. Okay, so then let me just print from here. Just to make sure this is being called on every frame. And it is, that's great. And then I'm gonna have this points array. And based on the time, I'm going to decide whether or not to add a new point to this array. So I'll say if the length of the points is less than the get value times, I'll say times points per second. I'll put points per second at like 5. Then I'm going to add to the points. Let's say, I'll just comment, I'll say add a new point. And this is going to have to be sampled from within the square. Okay. So the way to do that, random.random will give a point between 0 and 1. So I can say square bottom left will be... well, here's what I have to do. I have to do square left equals square dot get left. At 0, because it returns a point. Square bottom, square dot get bottom. I'll take the y coordinate of that. So square bottom left is going to be right times square left. The square left is a negative number, I think. Plus up times square bottom. I'm just going to put a dot there, actually. So then I'll say self.add well dot equals dot move to square bottom left. Then I'll just add that dot. Hopefully we'll see a dot at the bottom left of this, and great, we do. Now this is good because now we can sample from within the boundary of the square by choosing 2 random numbers between 0 and 1. So I'm going to say sample x value. This will be random.random. That's between 0 and 1. I'm going to multiply by the width of the square. Square.getWidth. Okay, that's going to be the x coordinate. With the y coordinate. I'm going to do something very similar, but with the height. So now let me just add this dot to right times sample xval. Actually, I'm going to just do numpy.array with sample xval, sample yval 0. And that is too far. And why is it too far? So starting from here, oh, I have to offset it by the square bottom left. Shouldn't you use shift instead of move to? It can be done with shift. In order to do shift, it'll be starting at the origin, and I'd have to take a random number between 0 and 1, subtract a half, and then scale it by the width of the square. But it is possible to do that way as well. Yeah, I do have to start it from the bottom left though. So I should say dot position This is going to be square bottom left plus plus this basically. All right. Great. So these are being sampled inside of the square now. Cool. So next, I'm going to color them based on whether or not they're inside the circle. That's what I'm going to want to do. Which means I have to find out if it's inside the circle. This ended up being like more geometry than I expected, but I have to write out this equation pretty much every time to figure it out. So the equation of the circle is the radius squared, which I think that's 3, is equal to x squared plus y squared. And that's because I left it at the center. And so the way to test if a point is inside the square is to check 3 squared less than or equal to that point dot x, the x value squared, plus the y value squared. And if this is true, that should mean it's inside the circle. So there's the dot position. I'm going to say if 3 squared is greater than or equal to dot position at 0 squared plus dot position at 1 squared. I guess I could also take the norm of this vector, but then I have to check if it's equal to 0 and stuff, and I just don't feel like doing that. Okay, then it's inside. I'll just say inside circle equals true. Then like set it to false by default. Okay, now if inside circle, actually I don't even need to do that. I can just say if this is true, then dot set color blue, which is the color of the circle. Else I'll set that to red. Okay. Okay, so this is coloring them now. It's doing almost everything I want. All I'm going to want to do now is calculate a running estimate of pi based on how many of these are colored versus not colored. So, let me do it this way. I'll have, I guess the points is already here. I'm going to say points inside circle and just set this value to 0. Besides using equations like that on the position, is there any way to tell if a point is on the interior of a shape object? I think there is, but I don't know it. There's like a geometric formula you can use to tell if a single point is within the shape imposed by surrounding points, but I don't know it. I don't know how to do that. And it's not built into Manim, probably. Actually, it might be. But yeah, that's my answer, I guess. Okay, so points in circle at 0 right now. How do you compute pi with this? Well, the area of the square is the side length squared. The area of the circle is pi times the side length over 2 squared. I think it's something implementable. I don't think it's too hard to do. So the area of the circle divided by the area of the square divided by the area of the circle. I guess I'd want to do it the other way around. Area of the circle divided by area of the square. Area of the circle is this. Area of the square is s squared. Okay. Then I'm just going to multiply this out. This is a geometry / algebra lesson now. This is s squared divided by 4. And the s squareds will cancel out. Great. So I'm going to estimate these by saying pi estimate equals the number of points inside the circle divided by the total number of points. So let's say length of points. And I got to update both of these, obviously. Actually, I can probably just do... Yeah, this is fine. If it's inside the circle, here I'll say points inside circle plus equals 1. And no matter what, I'll do points.append whatever the middle was called, dot position. Okay, points inside circle is unbound. It looks like I can't reference this from here. So I'm just gonna save it to the square. So I'll say square dot points inside circle. Here I'll update mob dot points inside circle. This will be mob dot points inside circle. I'm gonna have pi estimate equals 0 out here. Which that also might be unbound, actually. Okay, so let me make sure that didn't crash. I'll just print out the pi estimate. Like so. And that does not look close to pi at all. And it actually shouldn't, because this is pi over 4. So let me multiply this by 4. Okay, and that looks like it's getting to be near pi, so I think this is on the right track. So let me just display that on the screen. And to do that, I'm going to have a decimal number. Yeah, a decimal number. I'll call this pi mobject. I'm going to add an update to this. Actually, maybe I don't need to. Nah, I will. Edit pi estimate. I'll just take a mob object and do mob dot set value square dot. Oh no, it's just pi estimate. And I want to add that. So I didn't position this, so it'll be in the middle of the screen. And it's not updating, so let's see why that's not happening. I should probably add the updater to it. That might help. But it actually didn't. But I want to keep printing this. Why would this stay at 0? Oh, you know what it might be? I think this pi estimate is different from the one being set in here. So I think this does have to be square. square.pi estimate here, mob.pi estimate there. And here, I can print square.pi estimate. See if that helps. Nope, now it's stuck at 4. Oh, no, great, perfect. It's doing what it's supposed to do. Now this is a really bad estimate so far, so I'm gonna see if I can add more dots in and see if I can get a better estimate going. I should also probably stop printing. So I stop printing there. And then I'm going to move this to the side. Next to square on the right. Yeah, okay. Also, I want more dots. It triggers me so much that the estimate is so bad. Okay, so then let's not just have this number here. Let's actually write the rest of the estimate. So I'll say pi approx is going to be LaTeX. It's going to be pi. I think I just need this. Then I have this dot. Okay, how do I want to do this? I'll put this next to the square on the right. Then I'll put this next to pi approx on the right. And so that should say pi approximately this. And then I'm going to add more dots. Why is the size of the digits changing? So I think the reason for that is because in the decimal number, the points are actually placed programmatically. They're not just read from LaTeX. And that saves time from having to render every single decimal in LaTeX. And so I think that's why. But in the meantime, I just got a LaTeX error, so yeah, this is even math tech. And the pi approx isn't there. And I'm gonna add more dots. I just get so triggered when this estimate is wrong. And actually, while I was preparing for this, I like waited a long time and just added a ton of dots. And it takes a long time for this to converge, actually. Like, much longer than you probably care to wait for. I wonder if that's too slow. It's actually not. Wait. Oh, I see something. I was doing something wrong. Here I'm saying if the length of the points is less than the time tracker, then I add a point. What this should be is while. Because the time could move up by more than 1 unit. So now if I make this 100, this might be too slow. Oh, it's still going. Let's see how that turns out. That's getting there. It still looks like it's going toward 3.1. Anyway, that's how you do something like this. So this went over a few concepts, including used updaters, used value trackers, and added a bit of a probabilistic flavor to it to round it all out. We'll see if this makes a better estimate. It almost makes me think I'm doing something wrong. It is going toward 3.1.